some of those other things that may exist. And I guess in the IOCG space we've seen what I think is two great examples by Minotaur. Firstly, the Prominent Hill discovery, where people have been talking for a long while about Olympic dams, hematite dominated, etc., but everybody was still hanging around or directly in the mag anomalies, and really Minotaur were the guys that went out and started really incorporating detailed gravity and good gravity modelling to get the Prominent Hill discovery. And then also I guess I saw a couple of years ago a presentation by Tony Belperio when he started. That was the first I'd seen of the IOCG type classification, and then those guys have followed that through and now coming up with the Jericho discovery. So I think that shows you that really we need to be looking at different models for the IOCG terrane. And I guess with time, those discussions of different models have waxed and waned, and they have included everything. In the early days, I think people were starting to compare IOCGs with magnetite-rich porphyries and with skarns and with African copper belt and Mount Isa and mantos, and it's been a bit of a convoluted story throughout the years. But I think it's good to have a look at some of those models. Now, when you look at economic production from IOCG deposits, really globally it's dominated by four terranes. So you've got the coastal belt in Chile and Peru, you have the Carajás district in Brazil, and then you have the two districts in Australia, the Cloncurry belt and the Eastern Gawler Craton. So I guess to sort of remove a bit of the noise, I thought let's just have a look at those four key belts that are really economically important in terms of copper production. So when you look at those terranes, you've got Peru. You have a couple of operational mines there, and basically there's one key mine, Mina Justa, in development. You look at Chile with its very long mining history. There have been a lot of deposits mined there in Chile. A lot of those on that list were in production before people had even been thinking about calling them IOCG deposits. And a lot of them we could debate till the end of the earth about whether they actually are or how they fit into the spectrum. And the other thing to note from Chile, I guess amongst all of these terranes, Chile is the terrane where IOCG deposits are actually being mined for iron ore, commercially being mined for iron ore. So that in Chile, people often talk about the IOCG deposits, and they also talk about the IA deposits, the iron apatite deposits that are mined for high-grade concentrates. The Carajás, there are a lot of deposits in the Carajás, and it's one of these terranes that shows a lot of variability. It's been dominated by Vale over the years since the big iron ore discoveries out there. The Carajás is probably the second greatest after the Pilbara iron ore terrane in the world, and they were discovered in the mid-70s, and since then it's more of these discoveries of different deposit types came online. If you look at the Carajás, it's one of these amazing places like northwest Queensland, where they have nickel laterites, they have copper gold mines, they have the massive iron ore mines, they have manganese mines, there's high grade gold, Serra Pelada and those types of mines. So it's one of these amazing terranes. The Gawler Craton, which is probably the giant of all IOCG terranes, or I'm sure it will be. I'd love to be still around in 50 years' time and see the mines that were happening out there. And of course, northwest Queensland, where we have those current or historic operational mines: Ernest Henry, Osborne, Eloise, Selwyn, Mount Elliott, etc., E1, Monikoff. And I guess what we're somewhat short on is in the development exploration pipeline. So I put Jericho up there as one deposit in northwest Queensland that's starting to come onto the books. So the grade tonnage comparison, we're short on time today, so I guess I should say I'm not going to talk about tectonic setting, I'm not going to talk about silicate alteration assemblage, and I'm not going to talk about host rocks. But what I wanted to have a good look at was grade tonnage, deposit distribution within terranes, and also a good look at the sulphide and iron oxide mineralogy of the different deposits. Primarily because those iron oxide and sulphide mineralogy are the key factors when you're exploring in terms of detection of deposits, particularly with geophysical means. So what you can notice from this is this big, massive blue lump in the middle, Olympic Dam, and it really highlights that it's head and shoulders above the field. Certainly in terms of tonnage, and it's right up there with grade as well. Although, you know, we need to take these plots with a grain of salt, because there are so many other factors in terms of how the grade is determined in the published mineral resources. You know, your cover, your metallurgy, your geometry, and everything. But they're the key points. Olympic Dam, head and shoulders above the rest. Interestingly, you look at Eloise, Osborne and Antis, which is in the Cutterjust district. It was developed by Avanco. It's now Oz Mineral deposit. Sit right up there on the high grade copper spectrum. Selwyn, obviously here in northwest Queensland, Alamoa in the Cutterjust, and Osborne as well here in northwest Queensland are the richest gold examples. The other point to note that becomes obvious is these Chilean deposits. So the Chilean deposits in grey sit basically down the low end of the gold spectrum. So, and you can see this is basically zero here. So that, and a couple of these deposits, Dominga and Santo Domingo, are actually, whilst they're slated as copper, iron and gold mines, they're essentially a copper starter project for later iron ore mines. So this is interesting, and I sat down last week and thought, well, let's put these terranes next to each other if we want to do a comparison in terms of size. And what you see here is the Chilean coastal IOCG belt, which essentially stretches from El Soldado, which is down in the south, which is more a manto deposit, but it's part of this same belt. So the first sort of classic IOCG, I guess, is here at Alaspino. And you head north up to through Candelaria is the massive example, which is now over 1 billion tonnes of resource, thanks to some great exploration work there by Lundin. And then you head north and you basically Mantos Blancos, and there's some other copper deposits. There's another one called Marimaca up being worked by a company called Coro, just out of Antofagasta. Which is reportedly an IOCG, and I suspect it's going to get into the hundreds of millions of tonnes of ore category. So you look at the size of this, that is 1,000 kilometres of stretch of the IOCG belt. And what this highlights, and I like the Chilean IOCG belt in terms of understanding IOCG systems, because it's so new and fresh and metamorphosed, I guess. Is that you start to understand, once you put a tectonic control on a mineral system, the size potential of that system becomes pretty enormous. So that we've got this very simple system here with the subducting slab under the Andes, and that has allowed us to develop this very large system. And what I've shown here on green, this is the upper Jurassic, lower Cretaceous sedimentary packages that host the mineralisation, and this is the upper Jurassic, lower Cretaceous intrusive units through that belt. And if you put the same scale diagram from our two Australian terranes next to this belt, you see there's the Cloncurry belt up in the north and the Gawler down in the south at the same scale. So I hadn't quite appreciated till I put them on the map at the same scale, is that, you know, we think we're exploring in northwest Queensland, the outcropping areas of the Cloncurry belt, etc. But it could just be the tiny part of a much larger system. So it's illustrative to start thinking, and you know, people have been looking off the edges under cover. Where do these terranes extend to, etc. over for quite a while. And then there is the Cutterjust, which is about the size of the terrain itself that's known to host mineralisation, is about the size of the Cloncurry belt. So age of mineralisation comparison. The oldest is the Cutterjust mineralisation. It's you know, latest Archean basically. Then you have the Gawler Craton and the Cloncurry belt clustered pretty tightly here together. And then you get down to the young Phanerozoic coastal belt in Chile and Peru. Interestingly, the Cutterjust has another dose of mineralisation here at about 1880 million years. It's reportedly related to a second large magmatic felsic pulse, so that there was, in the Cuttagust, there was a large magmatic episode back at, broadly coincident with the mineralisation ages here at the latest Archean, but then 1880 there was another dose of magmatism, and there was another set of deposits formed. Brevis and Estrella they're probably not IOCG deposits. They seem to be more tightly related to a magmatic type of deposit. Okay, so yeah, two things that I think are important and worth having a look at are the copper sulphide mineralogy through these terranes and the iron oxide mineralogy. So what I've done is just take the collection of data that I have and had a look and classified these deposits in terms of their copper sulphide species. So that on the left here we have the high copper species, basically your chalcocite, covellite, digenite, etc. Then you go through to your lower copper species, chalcopyrite and bornite, and then on the right is the chalcopyrite only mineralisation. So that was one classification. The other is the iron oxide mineralogy. So that basically one end the hematite, earthy hematite, steely hematite, and then magnetite over there on the right hand side. And before we get on to have a look at them, I was suggesting that why it's important to understand this mineralogy is obviously iron oxide impacts dramatically on your potential fields, and these are a couple of examples that show the differences between the Cuttagust, for example. This is the Salobo deposit, and you can see this is the gravimetric anomaly, and this is the magnetic anomaly over here, and they absolutely tightly hug 100% the current extent of the Salobo mineralisation. Okay, so it's a very, very, very tight relationship. And then the other, of course, that we all have seen here in Australia is the Stuart Shelf and Eastern Gawler Craton area, where you look at the magnetic and gravity data that are offset simply because you're changing your iron oxide mineralogy. So this is Carapatina with the magnetic inversion and the gravity inversion model, and likewise for Prominent Hill. So if you look at the copper sulphide species, this is the Cuttagust district. What I've done is take those three categories and label them from high copper species in red down to the lower copper species, sulphide species in chalcopyrite. And what you see is that there is a distinct characterisation in terms of your chalcopyrite-rich deposits down here, and then your higher copper sulphide species are up to the north. And this is actually, if you look at these deposits, GT46, Salobo, Furnace, and there are another couple along on that trend. That's called the Cinzento shear zone trend. And it has distinctly different sulphide mineralogy from the other deposits. I won't get into to why that is, because how long is a piece of string? So iron oxide, what we see, I've also classified all of these diagrams I'm going to show with hematite in red, trending through to magnetite dominated in blue. And what you see here in the Cuttagust district is that it's pretty much magnetite rich. There are a couple there that have a bit of hematite in them. There's two, Cristalino and Igarape Bay Limao here. And these others, Brevis and Estrella, they're yellow, but they essentially don't have iron oxide. They're the younger deposits that are more granite related. Okay, so in summary, the Cuttagust has a mixed sulphide mineral assemblage, copper sulphide mineral assemblage, and is magnetite dominated. Okay, we look at the coastal belt in Chile. These are the same legends and types of plots, and you can see that in terms of copper sulphide, the Chilean belt is dominated by chalcopyrite in the central portion, and then as you get to the north and the south, you start to see these different copper species, which is interesting itself, I think, in terms of if you start thinking back to how these IOCG deposits are actually related to these large felsic to intermediate magmatic events. is the case that we're getting more chalcopyrite, and you'll also see potentially more magnetite when we're closer to these magmatic episodes than when we're off the end, and potentially higher above these magmatic systems. Okay, the Gawler Craton, well, it is strongly dominated by the high copper species at these discoveries. I might add the caveat that if you go and look out on the Gawler Craton, particularly in the Stuart Shelf, where you're under a lot of that cover, you do find a lot of holes drilled into magnetite chalcopyrite systems, but the grade basically is so low that they don't really register when you're putting together a database of IOCG deposits. So high copper sulphide species and strongly hematite dominated out on the Stuart Shelf as well. Okay, so Cloncurry Belt. If you put together 1, 2, 3, 4, 5, 6 essentially deposits that I think are the key deposits documented in the Cloncurry Belt, you start to see that chalcopyrite, bornite and high copper species. And most of these, or well, all of these deposits seem to sit down on the chalcopyrite dominated end of the spectrum. And you look at iron oxide species, magnetite, hematite, magnetite, and coolthor, which essentially doesn't have much iron oxide. So it's a bit of a different story that Northwest Queensland stands out as something slightly different, which is chalcopyrite, magnetite dominated systems, which in itself I think presents a great opportunity. And finally, in terms of mineralogy, iron sulphide mineralogy, if you go back and look through these deposits, you find pyrite dominated, pyrrhotite dominated, the two of them, and pyrrhotite pyrite, there's 1, 2, 3, 4, 5 there. Okay, so what does this mean once you have a look at these different terranes? Should we be paying more attention to the following in Northwest Queensland? And I know that a lot of people in this room even have done that over the years, looking at these different aspects, but I think it's worth reiterating them again. So manto systems, we see these in Chile, essentially I believe because it's an underformed terrane, and that they're not so obvious in these other higher metamorphic grade terranes. Hematite dominated systems, well, they're the characteristic on the Gawler Craton, and they are great targets. I know we've looked, and various groups have looked for those in Northwest Queensland. I remember seeing something at Amethyst Castle, I think it was called, out the back of the Selwyn trend, that looked like it might fit into this category, but I don't know whatever happened to it. But those hematite dominated systems, I tend to think in a very simplistic way of magnetite, hot and deep, hematite, shallower and less hot. So do we need to start thinking about, can we map vectors in the Mesoproterozoic terranes and rocks, metamorphic vectors, such that we can say, well, we are heading to shallower areas and we're going to be hoping to intersect those hematite dominated systems, and we need to modify our exploration strategies accordingly. And systems with high copper sulphide species and with low pyrite, certainly in Chile this is an issue because Chile has a heritage of porphyry copper exploration, which has been, you use IP for example to find your pyrite halo and shell, and then you vector into your potassic zone. So that's been an issue with IOCG exploration in Chile, and it also I guess impacts when you start thinking about exploring out here in Northwest Queensland. These high copper sulphide species, if you've got a deposit with covellite and digenite and bornite, and not a lot of pyrite in it, you're going to have a lot more trouble detecting that using electrical geophysics than you are with the higher pyrite systems. I don't know in Northwest Queensland if people here may know, but the high copper sulphide species, I guess I've seen them in deposits like I think it's Little Eva and Roseby. I think has a lot of bornite plus or minus covellite from memory. I don't know if there are any others out there. And that raises the whole question of those deposits in Northwest Queensland, and the immediate ones that come to mind are Roseby, Rocklands, and there's a couple of others that I don't understand where they fit on this this spectrum, so it'd be nice to know. Okay, so in summary, look, to date, copper production from IOCG deposits is dominated by those 4 terranes we spoke about, and they really span the geological history. So in comparing northwest Queensland with other belts, the heavily explored area, which is essentially the exposed and very shallow cover, is still a pretty restricted area when you think about the area of the mineralising system in the west coast of South America. The dominant iron oxide mineral discoveries to date in northwest Queensland are magnetite, and northwest Queensland to date has shown a smaller spread of iron oxide assemblages, so that maybe we need to be thinking about what things may look like in our data sets that are hematite dominated. And also there are no significant hematite dominated high copper sulphide species known from northwest Queensland. And so do we need to think about how we might be looking for those systems in terms of looking for things that at that what seems to be the mineralising time between 1600 million years, where can we go to find those shallower, lower metamorphic grade deposits? Okay, so that's the lot. Thank you, Helen.